Welcome to our first afternoon session in the first day of OVSCon 2019. Our first talk of the session will be OvS DPDK Acceleration with RTE Flow, Challenges and Gaps, and our speakers are Hemal and Sriharsha.
Thanks, Ben. As Ben said, this is a lightning talk, so we'll quickly go over. We have been working on vSwitch acceleration to expose NIC hardware offload capabilities for a long time, and specifically OvS DPDK. Recently, when we looked at it, where the current state of OvS DPDK, we found a bunch of gaps architecturally as well as implementation-wise. So that's what we'll quickly go over, and then we'll summarize with the next steps. Yes. Okay, so to begin with, if we look at architecturally, there are three things that I want to point out with offload. With any offload, generally there is a built-in capability discovery, which allows you to really take advantage of offload capability of a device, make intelligent decisions. So the current state where OvS DPDK is, that is non-existent. And then just using the flow validate kind of capability DPDK has is not sufficient. So this is one of the first gap that we see as architectural gap. The next one is when we look at from the offload action standpoint, especially from VO's user side, we look at there is currently no framework to do partial action offload, which includes the receive side and also on transmit side. In order to do that, you also have to still do the lookup, but then if you can offload partial actions, that framework will still give some benefit of hardware capabilities. So this is another gap that we see with today's acceleration or offload framework. And the third one, from SRIV standpoint, DPDK has this VF representative framework which you can use to have full offload, and then there are patches that are currently being reviewed and contributed to. But there are some challenges with that. There is no good management or CLI interface to manage this. Also, there are some restrictions here because the whole VF creation destruction is still handled through kernel. So this doesn't allow you to have a framework where your physical function driver is in DPDK environment, and then you manage VF representative from that. So a lot of this VF representation creation destruction, those are becoming more like vendor specific. So a possible solution there is you can dedicate a VF pole mode driver just for this kind of VF representative management. So that's a potential solution, but there are definitely some gaps here from the management side. So those are the key three architectural gaps. We have seen the capability discovery, partial actions offload, and how you manage the VF representative. Let me hand it to Harsha. He's going to go over some of the implementation gaps we have seen, and then we'll wrap up with some offload consideration.
Thanks. So looking at some of the implementation gaps, the first thing is the actions offload, right? Today, with partial offload, we have support for mark and RSS actions, but to be able to do more, we need support for other actions like drop, count, encap, decap, metering, and output, right? Some of them might apply only to partial offload, and then something like output would apply only to full offload. So we need extensions to these actions that are offloaded. And then if you look at the control plane APIs, today we only have support for add and delete. You can offload, you can create using RTE flow offload, right? You can add a flow to the hardware and then you can delete it. But what you don't have is dumping the flow, flushing, and getting a stat information for the flow. All these need to be supported. Like Hemal said, there is a bunch of recent offload patches that try to address this for full offload. And one other area is we need error reporting. So we need a lot of refinement to get the errors properly detected from the PMD and basically send it up to the stack so that we can take the right steps to handle those errors. So one of the other things that we need to look at is a feature called dynamic rebalance that we added in the kernel mode for TC offloads. We need something similar in OvS DPDK, but there are some differences with respect to how the data path handles the flow offload. Right? In the kernel mode, a flow gets added to both to either the data path or hardware. But in OvS DPDK, the flow is added to both the data path and hardware. So the way we handle the errors and how we take care of the the dynamic rebalance logic, that needs some consistency with respect to both kernel and OvS DPDK. And related to that is handling of these specific errors, such as like space when you run out of resources in the PMD. That is something that has to be done in all the PMDs. And then we need error propagation. Once you see that error from the PMD, that needs to go up to the stack to all the way up to OFPRO to DPIF, where we handle the rebalance logic.
Yeah, so I think since this lightning talk, as you saw, there are a bunch of architectural gap, implementation gap. We saw this in the presentation before on this OpenStack OVN integration. There are also gaps there. So in conclusion, it's not quite ready. The framework is not quite ready to take advantage of the offload capabilities that are out there. So really need to work on advancing and improving the acceleration and offload capability with OvS DPDK. With that, I'll conclude.
Let's thank our speakers. Thank you. So